If anybody's a Star Trek fan, you probably already know this, and a lot of people in IT for some reason are. So in the Kobayashi Maru is a test that's given to all Starfleet captains before they graduate, and in the films it's a non-winnable scenario. So the captain's faced with a situation where he's asked to rescue the Kobayashi Maru, and as he approaches the ship, in his ship, just in case you're not a fan, a couple of enemy ships decloak, and he's got 3 enemy ships and the ship that he's trying to save. So he has a choice. If he tries to save the crew of the stricken ship, what happens is the enemy ships blow him to pieces. Alternatively, if he tries to engage the enemy ships and defeat them before he rescues the crew, while he's engaged with the enemy ships, the crew of the ship, the Kobayashi Maru that he's trying to save, all die. So at the end, you basically can't win. In the films, Kirk, basically the way that he wins, he's the only person to ever successfully rescue the crew. But the way that he does that is he reprograms the scenario, so he changes the rules so that he can win. And so the reason I entitled this talk the reason I used Kobayashi Maru in the title of the talk was because I believe that in software development we faced the challenge for a long time where we're in a no-win situation, and we've identified the fact that we really quite often can't deliver everything that people want. And so Agile has been a way of trying to manage that situation and deliver the most important things first, but we're still in a situation where quite often people get less than they desire because we just don't have time, we don't have budget to deliver more functionality. So one of the things I was thinking about, in order to deliver more functionality, we really need to be more efficient in our software development. How can we write software by writing less loads of code? And so to do that, maybe we need to step back and look at rethinking the way that we approach the problem. And so through that and through some other things that I've been doing, I've got quite interested in functional programming and whether that's a solution. I had a friend who was doing a PhD at Cambridge about 4 or 5 years ago, and he happened to mention to me, as part of his PhD, he was writing some software. And the software that he was writing in functional programming, and I had no idea what he was talking about. And really I wasn't that interested because I thought, I've never heard of it, and basically mainstream programming, we do everything object orientated, Java or C# tend to be the predominant languages. So I really didn't give it much thought. And then gradually I heard a couple of other people talk about it over the years, you know how things go. And somebody gave me a book probably about a year ago called Painters and Programmers, and in that this guy from America talks about the fact that he ran a business that was really successful and was eventually bought by Yahoo. But one of the things that made it really, really successful was that they could get out their software faster than anybody else. So they could deliver more features in less time, which gave them a distinct market advantage over their competition. And the reason they could do that was that they were writing in Lisp, which is a functional programming language. And he was talking about the fact that he thought that functional programming gave him a business and competitive edge over everybody else. And that's what really got me interested in functional programming. One of the things that we often talk about when we talk about architecture is we talk about loosely coupled systems and we talk about scalability. And we achieve that mostly by writing quite large chunks of code usually, which are loosely connected together. But the actual code itself is usually quite tightly coupled. I mean, as soon as you do object-oriented development, you're instantly coupling your data with your methods. So you've got a tight coupling there. And so quite often you find that actually you'll have a piece of code that actually, or you could reuse the piece of code, like you've got a method that you want to reuse, but the method's been written to use data that's coupled to that class. And so quite often what we do then is, you end up either having to cut and paste it somewhere else, in which case you end up with a maintainability problem, or you'll abstract it into some class that you try to share, which sort of gets a bit clunky when you're trying to do object orientating. If you're doing functional programming, everything's written in, so there's no tying the data and the functions together. So typical function like a maths function, like taking the sign of a number, doesn't matter what the number is. You can easily pass it in and you get an answer out. And so what happens with functional programming is, because things are much more loosely coupled at a much more granular level, it's a lot easier to reuse code. So one of the advantages you get is the stuff that you wrote maybe last year or last month or on a different project is much easier to reuse. And the other thing is, just because the stuff is smaller, it's more flexible, and there's a lot of other things that you see in functional programming that make it quicker and easier to write within, and you usually write less code. And obviously if you spend less time writing code, you have to spend less time thinking about what you're going to write, and it compresses the whole process. So I think what's probably going to happen is most large organisations are going to continue to do what we currently do, which is completely ignore it. And I think I can see one of two things happening: either young people that are coming out of university who are doing functional programs. So there's a course at MIT which no longer teaches object-oriented programming; they only teach functional programming. So as some of these young guys come into the organisations, they'll probably be a bit disheartened that we make them do the good old-fashioned way with the quill pen and everything. But eventually, obviously, as they rise up through the ranks and they get to the point where they have an influence, then we may see a transition then. Alternatively, I think what we may see is young startup companies or some other company that's in competition with you, if they start to produce, deliver functions and features faster to the market than you can, or we can, then I think we're going to be forced to readdress things, and then people are going to look and think, how come they're doing stuff quicker? How come they can get out 5 new functions in a week and we can only do 3 functions in a week? And if the answer to that turns out to be functional programming, then I think lots of the bigger corporations are going to say, right, well, we need to do things that way.